Earth Science, Chapter 6, Section 4, Earth's Natural Resources, Digging Deeper, Energy Resources and Their Impact on the Environment. Fossil Fuels and the Carbon Cycle. When a fossil fuel is burned, its carbon combines with oxygen to yield carbon dioxide gas. Fossil fuels supply 82% of the primary energy consumed in the United States. They are responsible for 98% of the country's emissions of carbon dioxide. The amount of carbon dioxide produced depends on the carbon content of the fuel. For each unit of energy produced, natural gas emits about half of the carbon dioxide produced by coal. Petroleum fuels emit about three-quarters. Scientists are trying to find out what is happening to all of this carbon dioxide. They want to know how it affects the Earth's system. According to the first law of thermodynamics, the amount of energy always remains constant. The amount of chemical energy consumed when a fossil fuel is burned equals the amount of heat energy released. Scientists think of matter in a similar way. Matter cannot be created or destroyed. The law of conservation of matter helps you to understand what happens when one type of matter is changed into another type. For example, fossil fuels consist mainly of hydrocarbons. They are made up of hydrogen and carbon. When a fossil fuel is burned, the carbon is changed chemically into carbon dioxide. The amount of carbon used equals the amount of carbon produced. The carbon never goes away. It moves from one reservoir in the Earth system to another. Previously, you may have learned about the carbon cycle. It is the idea that many processes work together in a global movement of carbon from one reservoir to another. You have learned about several important reservoirs of carbon. The atmospheric reservoir of carbon is carbon dioxide gas. Biomass contains carbon, mostly carbon in plants. In the geosphere, carbon is found in soil as well as in solids such as coal and limestone. It is found in liquids such as petroleum hydrocarbons. It is also found in gas. The ocean is the largest reservoir of carbon, found in the form of bicarbonate salts. Photosynthesis and respiration cause most of the movement of carbon dioxide between the atmosphere, land, and oceans. The wide blue arrows show this flux in figure 1 below. I'm sorry. This is figure 1. So the wide blue arrows show the flux. The smaller red arrows show the flux of carbon due to human activities. Natural processes such as photosynthesis can remove some of the net 6.6 billion metric tons of anthropogenic carbon dioxide emissions produced each year. This means that an estimated 3.3 billion metric tons of this carbon is added to the atmosphere annually in the form of carbon dioxide. By measuring concentrations of carbon dioxide in the atmosphere over time, scientists have learned that levels of carbon dioxide in the atmosphere have increased about 25% in the last 150 years. See Figure 2 below. Scientists believe that human activity has caused this growth. This coincides with the beginning of the Industrial Age. This increase is due largely to the burning of fossil fuels and deforestation. How does this affect the Earth system? Carbon dioxide is one of several greenhouse gases. These are gases that slowly escape of heat energy from Earth to space. Some scientists believe that the rapid addition of carbon dioxide to the atmosphere is changing the energy budget of Earth, causing global climate to warm. Coal and acid rain. Acidity is a measure of the concentration of hydrogen ions in an aqueous solution. A solution with a high concentration of hydrogen ions is acidic. One with a low concentration is basic. The concentration of hydrogen ions is important. This is because they are very reactive with other substances. Mixing acids and bases can cancel out their effects. This is much like how mixing hot and cold water evens out the water temperature. That is because the concentration of hydrogen ions in the mixture is between that of the two original solutions. A substance that is neither an acid nor a base is said to be neutral. The pH scale shown in Figure 3 measures how acidic or basic a substance is. It ranges from 0 to 14. A pH of 7 is neutral. A pH less than 7 is acidic. A pH greater than 7 is basic. Each whole pH value between each whole pH value below 7 is 10 times more acidic than the next higher value, meaning that the concentration of hydrogen ions is 10 times as great. For example, a pH of 4 is 10 times more acidic than a pH of 5 and 100 times, 10 times 10, more acidic than a pH of 6. The same holds true for pH values above 7, each of which is 10 times more alkaline, another way to say basic, than the next lower whole value. For example, a pH of 12 is 10 times more alkaline than a pH of 11. Pure water is neutral. It has a pH of 7. Natural rain, however, is mildly acidic. Its pH is about 5.7. The reason is that carbon dioxide in the atmosphere dissolves in rain. Some of this dissolved carbon dioxide reacts with the water to form a weak acid called carbonic acid. As the carbon dioxide content of the atmosphere has gradually increased in recent decades due to the burning of fossil fuels, natural rain has become slightly more acidic. This is in addition to the serious problem of acid rain caused by sulfur dioxide. You learned that coal contains as much as 5% sulfur. When the coal is burned, the sulfur is emitted as sulfur dioxide gas. The sulfur dioxide then reacts with oxygen and then with water in the atmosphere to form sulfuric acid. This is a strong acid. The last reaction in this process is written as follows. Some of the sulfuric acid then dissociates into hydrogen ions and sulfate ions in solution in the water. This reaction can be broken down into two parts as follows. The hydrogen ions reach Earth's surface dissolved in raindrops. This happens either over land or over the ocean. Burning of fuels also produces nitrogen oxide gases. These gases react with water to form nitric acid, another strong acid. Some of the nitric acid breaks down to release hydrogen ions by a reaction similar to that of sulfuric acid. Burning of coal is not the only source of sulfuric acid and nitric acid. Petroleum-fueled power plants, smelters, mills, refineries, and motor vehicles produce these acids as well. Acid rain is especially damaging to lakes. If the pH of lake water becomes too acidic from acid rain, it kills fish, insects, aquatic plants, and plankton. Environmental scientists Environmental scientists describe lakes that have suffered heavily from acid rain as dead. This is because the entire food web of the lake has been disrupted to the point where little is left alive in the lake. Acid rain is a serious problem in many areas of the United States. The biggest problem is in the Northeast. The reason is that there are a large number of coal-fueled electric power plants in the Midwest. This is especially true in the heavily populated areas of Ohio, Michigan, and Illinois. These plants burn mostly the relatively high sulfur coal that is mined in the interior coal province. Winds blow mostly from the west to east in the mid-latitudes of North America. This tends to bring the acids to the northeast, where large amounts fall with rain. Another reason for the impact of acid rain in the northeastern United States has to do with the types of rock and soil in that region. In the Investigate, you learned that limestone has a greater ability to neutralize acid than granite. If the soil upon which acid rain falls is rich in limestone, the acid rain may be neutralized. Also, if the underlying bedrock is either composed of limestone or marble, then the acid rain may be neutralized. This is because limestone and marble are more alkaline. They produce a higher pH when dissolved in water. The higher pH of these materials dissolved in water offsets or buffers the activity of the rain. This produces a more neutral pH. If the soil is not rich in limestone, or if the bedrock is not composed of limestone or marble, then no neutralizing effect takes place. The acid rain then accumulates in the bodies of water in the area. This applies to much of the northeastern United States. There, the bedrock is typically composed of granite. Granite has no neutralizing effect on acid rain. Therefore, over time, more and more acid precipitation accumulates in lakes and ponds. Coal supplies about one-third of all electricity generated in the United States. In recent years, the problem of acid rain has grown. Because of this, various technologies have been developed. Their purpose is to reduce the emission of sulfur dioxide from coal-fueled electric power plants. The general term for these processes is flue gas desulfurization. It is also called scrubbing. Several kinds of scrubbers are used. The most common is the wet scrubber. In wet scrubbing, the flue gas from the power plant is sprayed with a calcium carbonate solution in the form of a slurry. The SO2 is oxidized to form calcium sulfate. Scrubbers of this kind can remove up to 95% of the SO2 that is emitted from the power plant. Scrubbers can have a useful byproduct. Certain kinds of scrubbers are now in operation that produce pure calcium sulfate as a byproduct. The byproduct, gypsum, can then be used industrially to make plaster and wallboard rather than having to be mined and processed. Oil spills in the environment. In the previous section, you learned that oil is one of the world's main sources of energy. The global consumption of petroleum has risen from 21 million barrels per day in 1960 to over 96 million barrels per day in 2016. In the United States, it is the primary energy source, but as you determined, the United States does not have enough oil to meet its consumption needs. It must import oil from other parts of the world. Because oil is unevenly distributed, it must be transported by ships across oceans and by pipelines across land. By far, the greatest oil reserves are in the Middle East. Major transportation routes originate from there. The massive transport of oil around the globe sometimes results in accidents. Oil spills occur when oil is transferred to vessels, as it is transported across oceans, and when pipelines break. They can also occur during drilling operations. While massive and catastrophic oil spills receive most of the attention, smaller oil spills occur regularly. In 1974, approximately 120 spills greater than 7 metric tons occurred. 40 years later, this figure has fallen to less than 5 spills. While shipping has become safer, there is always the risk of a major spill along shipping lanes. When oil spills do occur, the impact is often felt in places outside where the oil originated and where it was destined for delivery. The far-reaching effects of oil spills can provoke the far-reaching effects of oil spills can provoke serious international tension. The impacts of oil spills include contamination of coastal and marine ecosystems as well as human health problems. When oil spills occur in the ocean, waves, ocean currents, and wind often move the oil on shore. When oil reaches the coast, it interacts with sediments such as beach sand, gravel, rocks, and boulders. Beach sand and gravel saturated with oil may be unable to protect and support coastal vegetation. Rocks and boulders coated with oil can be toxic to coastal wildlife. Marine oil spills can also be harmful to deep ocean and coastal fisheries. Oil residue is not only toxic but sticky. As a result, marine life can be poisoned and smothered. Oil can also contaminate bottom organic matter, interrupting the marine food chain on which fish and other organisms depend. Oil spills can affect humans as well. There are potential health impacts that can result from oil spills. These include accidents suffered by those on damaged tankers and drilling platforms. Those who inhale toxic fumes or eat fish or shellfish contaminated by oil can become ill. Many coastal areas are heavily populated. They also tend to provide recreational activities such as fishing, boating, swimming, and scuba diving. When oil invades these areas, housing values decrease and recreational activities decline. This can have long term effects on the local economy. The Deepwater Horizon oil spill. The Deepwater Horizon oil spill is the largest accidental marine oil spill in history. It was caused by an explosion on the offshore oil platform in the Gulf of Mexico. It took place about 80 kilometers southeast of the Mississippi River Delta on April 20th, 2010. The platform sank in about 1,500 meters of water 2 days later. Most of the 126 workers on the platform were safely evacuated. However, 11 workers were never found. The sinking of the platform caused crude oil to gush out of the riser. The riser is a pipe that connects the well at the ocean floor to the drilling platform on the surface. Initial attempts to shut down the flow failed. A safety device called a blowout preventer could not be activated. Another series of efforts, including covering the well with a 125-ton containment dome, also failed to stop the leak. Finally, on July 15, 2010, a containment cap stopped the flow of oil into the Gulf of Mexico from the gushing well for the first time in 86 days. Shortly thereafter, cement was pumped into the well to seal it permanently. The exact amount of oil that flowed into the Gulf of Mexico has been controversial. A team of government scientists has stated that the final amount of leaked oil is close to 4.9 million barrels. The oil slick produced was huge. It covered as much as 75,000 kilometers squared, 75,000 square kilometers. This is an area about the size of South Carolina. About 6 weeks after the explosion of the platform, oil had come ashore in Louisiana, Mississippi, Alabama, and Florida. In those weeks, a lot of wildlife died. Scientists also discovered enormous oil plumes in the deep waters of the Gulf of Mexico. This raised concerns about impacts to the marine ecosystem far below the surface. These impacts would be difficult to assess. This image was taken by NASA's Aqua satellite on June 19, 2010. It shows oil spreading in a northeast direction from the leaking Deepwater Horizon well. Efforts to clean up the spill and limit its damage included the use of fire booms. These are U-shaped devices that were towed behind boats and used to pull oil to controlled areas for safe burning. Dispersants were also sprayed on the oil. These chemicals change the chemical and physical properties of the oil in order to reduce its potential effects. Sand berms were also constructed along the Gulf Coast to capture oil from the spill. The Deepwater Horizon oil spill is considered by many to be the worst environmental disaster the United States has ever faced. Since the oil spill, thousands of dead animals have been collected. This includes birds, sea turtles, and dolphins. Hundreds of thousands of people and businesses were also affected. These businesses depend on the beaches and marshy bays of the Gulf Coast. Scientists predict that the threats posed by the oil spill will continue for many years to come. Advantages and disadvantages of energy resources. Energy resources affect the community in many ways. Some ways are positive, others are negative. Energy resources allow you to maintain a very high quality of life. They also indirectly provide jobs for many people. Yet the use of them can have obvious and subtle negative impacts. One of the most obvious negative impacts is a deterioration of air quality. This is due to the burning of fossil fuels. More subtle impacts include acid rain, possible global warming, and groundwater contamination. They can also be a financial burden on households. It is important to realize that you can help to reduce these negative impacts. Personally, and as a member of the community, you can control how you use energy resources. You can control how you use energy resources.